The question assumes that he has sexual desires for children. Does everybody understand that? So there's no way to answer the question without making an admission that you don't want to make. Does everybody understand that? If someone asks you, do you always beat your wife after your football team loses? Well, it doesn't matter how you answer, you're going to be admitting that you beat your wife on occasion. Does everybody understand that? Okay. What happens if someone asks you a complex question? Just say, I don't understand the question. And keep repeating that until they ask why, and then you say, because it makes this assumption, which is false. Everybody got that? Okay. All right, so the next section area is titled Gray Areas. The first fallacy in this is slippery slope. Okay. Now, you all know what a domino effect is. You've heard of this expression. It's like if you do this one thing, it will lead to this other thing, and you'll start this chain reaction, right? And a slippery slope is saying something like this. If you do so-and-so, it's going to lead to this chain reaction, and that chain reaction is going to lead to something awful. So don't do this first thing, because it will end up to this awful thing. And it's a fallacy when that chain reaction is unlikely to occur and end up at that disastrous event. Does everybody understand that? So they're implying that there'll be this disastrous chain reaction when in fact that disastrous chain reaction is actually unlikely. Okay? For instance, I'm reading passage 134. Becky wants to go to the movies with a group of her friends, Sheila, Shelley, and Samantha. It's not a good idea. I know that Samantha is a good driver, but if we let Becky go to the movies with her friends, the next thing you know, she'll want to go to the movies with a boy. You know what teenage boys are like. He will certainly talk her into the back seat of his car. The next thing you know, Becky will be dropping out of high school as an unwed mother and live the rest of her life on welfare. In this case, as her mother, you have a duty to forbid her to go to the movies with her friends tonight. Do you think that's a likely chain of events? No. Slippery slope. Everybody understand that? Okay? So, look, slippery slope is often used by the gun lobbies. They say, hey, look, if we have to register our weapons, they'll know who has the weapons, they'll make the weapons illegal, they'll come and seize our weapons, and then we'll live in an authoritarian dictatorship where we have no way to defend ourselves. Unlikely to happen. Okay? All right, so after slippery slope, what do we have? Line drawing fallacy. Okay, I don't want to use the example I have there, but line drawing fallacy. Sometimes it's hard to draw a line between this and that. For example, drunkenness comes in degrees. Does everybody understand that? Okay, you can be slightly tipsy, fall down drunk, right? And we know if someone is drunk, they can't really consent, right? If you get your friend to sell them, or for them to sell you their car for $1 when they're drunk, well, that sale's not morally binding. Does everybody understand that? Or legally binding. But the question is, when are they drunk? Right? And it might be hard to point, to draw a precise line between when they're not drunk and when they are drunk. So there's a gray area. Does everybody understand that? But that doesn't mean that there is no distinction between being sober and being drunk. And the line drawing fallacy says, it's hard to draw a line between this and that, so there's really no difference between this and that. And that's simply false. Does everybody understand that? Okay. And a lot of times, people bring up the line drawing fallacy by simply saying, where do you draw the line? Okay? And they're assuming since it's difficult for you to draw the line in any specific place, there is no line to be drawn, and that's the fallacy. Does everybody understand that? Okay. Okay. Fallacy of composition and division. Okay, these are two different fallacies, but I confuse them a lot, so I put them together. Okay, but the fallacy of composition and division are closely related, blah, blah, blah. The fallacy of composition occurs when all or most of the parts of some whole have a certain attribute or quality, and therefore the whole is also claimed to have that same attribute or quality when it doesn't. Okay, so for example, suppose that I take apart my motorcycle, take apart the engine all the way, and it turns out that I can pick every piece up of my motorcycle and lift it above my head. And so I say all the parts of my motorcycle are liftable, upable. Okay? So I conclude if I reassemble my motorcycle, I will be able to lift it above my head. Does that follow? No. Just because the parts had a certain quality doesn't mean that what? The whole does. And the fallacy occurs when you say the parts have a quality, X, and therefore the whole has a quality X when it doesn't. Okay? Now sometimes we might not know whether it would or wouldn't, and in that case you just ask. Everybody understand that? And sometimes because the parts have a quality, does mean that the whole has to have that quality, right? If I make a building out of all red bricks, what color is the building going to be? Right? Yes? Okay, does everybody understand that? Okay. All right. The fallacy of division goes the other way. I say this thing, this whole, has a certain quality, therefore all of its parts must have the same quality. Okay? So for example, a cake. A cake is delicious, right? And it's hard to think about a cake having parts, but think of ingredients as parts. Okay? So I say to myself, cakes are delicious. I don't have time to make or bake a cake, but I'll just go down to the store and buy some of the ingredients because they must be delicious too. Does it follow that the ingredients are going to be delicious by themselves? Answer? No. Does everybody understand that? So you go to the store, you buy some raw eggs. How's that going to taste? Not so delightful, right? Or vanilla extract, plain. Not so good. Does everybody understand that? So composition, parts to the whole, division, whole to the parts, when it doesn't. Everybody got that? Okay. Okay. Next up, I'm on 136, hasty generalization. Okay. Now, all throughout the book, we have thought of generalizations as something very specific, and that trend continues here. So don't just say fallacy, hasty generalization because you encounter a claim that seems like a general claim. Don't do that. A hasty generalization, first of all, what is a generalization? It's a claim about a population, an entire population, based on a sample of that population. Does everybody understand that? So a hasty generalization is when you've made a generalization on insufficient grounds, okay? And there's a number of ways that you can do it. The first is the sample size is just too small. For example, I'm reading passage 140. The students at Faber College overwhelmingly wish to expand the number of Greek organizations on campus, more fraternities and sororities. all 3 students interviewed for the survey thought that the college of 10,000 students would be greatly enriched with more Greek organizations on campus. 3 people out of 10,000 is much too small of a sample. Does everybody understand that? So we would say hasty generalization, sample size is too small, okay? But we can even have large samples and it not be any good. For example, now reading 141. The students at Faber College overwhelmingly wish to expand the number of Greek organizations on campus, more fraternities and sororities. All 500 fraternity members and all 500 sorority members interviewed for the survey thought that the college of 10,000 would be greatly enriched with more Greek organizations on campus. So now we have a sample of 1,000, which is 10% of the student population. That's a large sample. Why is this no good? Why is this a hasty generalization?
It's all fraternity members?
Yeah, it's all fraternity members. So the sample is unlikely to be representative, okay? How do you prevent against that? You make sure that your survey is random, okay? That you select people at random. Now, what does it take for a sample to be random? It's this, that each member of the population has an equal chance of being selected for the sample. Does everybody understand that? So everybody has an equal chance of being selected, okay? And so there are some famous examples of surveys gone wrong and getting bad answers. So, for example, this was back in the 40s or something, there was a presidential campaign going on, and this survey company said, hey, we're gonna figure out who's gonna win this election. And remember, this is way back in the 40s or whatnot. And so they did a random phone survey. They said, who are you voting for? They all said, so-and-so.